Chapter 2, Lesson 7, looking at two variable inequalities and graphing those. And we talked about when we're graphing inequalities that we need to shade the region where the solutions are found. And we did that with linear inequalities, and the region, the line becomes the boundary between the region where the solutions are located and where those are not located. And we remember that when we graph these lines, if the line itself was included as the solution greater than or equal to, it was solid, and if they were not included, it was dotted. Now we're going to use the exact same process when we're graphing these absolute value inequalities, and again we're going to use the exact same tools that we use to graph these absolute values, and then we're going to find the y-intercept, and then we're going to graph above the inequality or above the absolute value graph or below. So it really is the exact same steps to success that we talked about when we're graphing linear inequalities. There isn't anything new here, so it's really a review of graphing absolute value inequalities and then just applying what we learned about being dotted or solid as far as the boundary, and then graphing above or below. So we'll need to determine if the rays are solid or dash, greater than or equal to. We'll use what we learned in lessons 5 and 6 to graph the absolute value equations. We'll locate the y-intercept, and then we'll figure if we need to shade above the rays for a greater than or below the rays for a less than. So let's go ahead and do a couple of examples. So I have 3 examples that we'll do. We'll take a look at this one first. The absolute value of x plus 3 is greater than y. So again, I like to have the variable on the left, so I'm going to switch these around. So actually I'm going to have to use the symmetric property. So I'm going to make this as y is less than, reading from left to right, or excuse me, right to left, y is less than the absolute value of x plus 3. So now I have what I need, so I'm going to go ahead and label my graph, put my appropriate markings on here, and then I'm going to graph the absolute values like we did before. So we're going to need to find the vertex. So there's a horizontal shift of 3 to the left, and there is no vertical shift, so my vertex is at -3, 0. So I'm going to put that point there. The slope is a 1 because there's a 1 next to the x, so I'm going to go ahead and go up 1 over 1 for the first ray, and up 1 and over 1 for the other ray. And then I notice that the y is less than, the rays are not included because it's not equal to, so I'm going to use a dotted line for my rays. Okay, so and the absolute value is positive, so it's going to open up. So my rays are going to go up like this. Okay, so I have my absolute value graph now. So all I need to determine now is where am I going to shade? Am I going to shade above or below? And again, we're going to do the same thing we did before. We're going to go to the y-intercept, which is right here, and we're looking for y's that are less than this one. So if I walk down, I end up less than those, and I end up on the outside of the V. So I'm going to shade everywhere outside the V. All of these points out here are going to make this inequality true. So again, we're just combining what we already know about graphing absolute values, and then what we learned in the last lesson about when to use solid lines or dotted lines, and then how to figure out where to graph when you're using the y-intercept, or how to use that to help us know where to shade. Okay, and again, make sure you label these points, okay, and then we're shaded, so that would be an example of an absolute value inequality. So let's take a look at another example. So our second example here, we have y solved for already. Y is less than or equal to 3 times the absolute value of x minus 2 plus 1. So I know the shape of this graph is going to be a V because it's an absolute value. So I'm going to put my markings on here. So we're going to find the vertex first. So this is a horizontal shift of 2 and a vertical shift of 1. So my vertex is going to be at the point 2, 1. And now I'm going to go ahead and graph this, or label this 2, 1. Now I have a vertical stretch of 3, so this is now my slope of my rays. I put the 3 over 1. So from the vertex, I'm going to have a rise of 3 and a run of 1. The absolute value is positive, so I know it's going to open up. So I am going to go up 3 and over 1 for 1, and then up 3 and over 1 for my other ray. Now it's less than or equal to this time, so that means the boundary lines are included. So in this case I'm going to use solid lines then. So I'm going to have a solid line here and a solid line here. And now all I need to do is determine where I'm going to shade. So I'm going to find the y-intercept, which is right up here, and I'm looking for y's that are less than that. So I'm going to go down, and I end up again outside the v, so I'm going to shade everywhere outside the v. Any of these values out here are going to be solutions to this expression. Okay, so we're going to go ahead and shade out here. And I would suggest you do a nice light shading out here. When we look at intersection of these, we'll talk about that later. It's really important that you do a nice shading and not just scribble, because it's going to be hard to see where they overlap in future lessons. But all of these would be the shadings, and again, solid lines because those are included. So I have one more example, so let's take a look at that one. So here's our final example. So we have the absolute value, the opposite of the absolute value of x plus 2 minus 3 is greater than or equal to y plus 2. Now I'm going to solve this for y first, and then I'm going to switch everything around. So I'm going to add this 2 to the other side. So that's going to give me the opposite of the absolute value of x plus 2 minus 1 is greater than or equal to y. So then I'm going to, no, I'm sorry, I had to subtract 2, so that's going to be minus 5 actually. I'm going to subtract 2 from each side, so you see that. All right, so then I'm going to switch this around so it reads from right to left, or from left to right. So y is less than or equal to, and then I have the negative absolute value of x plus 2 minus 5. So now that I have this, I can go ahead and graph, and again, I need to label my axes and put a scale. Make sure you're doing that on every graph. And then I'm going to have to graph this absolute value, so I'm going to find the vertex. So there's a horizontal shift to the right, excuse me, to the left 2, and then down 5. So my vertex is at negative 2, negative 5. 1, 2, 3, 4, 5 right here. So this is about negative 2, negative 5 right here. Okay, then it's less than or equal to, so I'm going to use solid lines, and I have this negative sign here, which means it's reflected over the x, which means the v is going to open down. So I'm going to use solid lines because it's equal to, and my slope is 1, so I'm going to go from here down 1 and over 1, so puts me about right here, and from here I'm going to go down 1. That looks like that might be down 2. Let me fix that. So I'm right here, down 1, over 1, down 1, and over 1. All right, and then again, it's solid because those are included, so my v values, or my rays, are going to look like this. Now I need to determine where to shade, so I'm going to find the y-intercept, which is right here, and I'm looking for the y's that are less than this, so those would be the y values down here. When I get down here, I end up inside the v, so that's where I'm going to shade, is inside the v, and all of these y values in here are less than or equal to the absolute value graph that I have here. All right, so those are some example on graphing those inequalities. So that's pretty much the lesson. I do want to talk about some problem solving tips, so let me go ahead and do that for you, and then we'll wrap up this chapter. Some things to remember when you're problem solving, and basically when we're looking at word problems. Again, we want to be careful to look for word or phrases that identify inequalities. Phrases like at least or the minimum number. When you say you need at least $10, that means you need to have $10 or anything more than that. So at least is actually a greater than or equal to sign. The minimum number, or the smallest amount you can have, is another way to say greater than. All right, because that's what they translate into. So when you're reading word problems, you want to understand what those mean. When you say you can have no more than 12 people in the car, that's a lot, but no more than 12 people in the car, that's actually a less than type of equation, because you cannot have more than 12, so you're looking for numbers that are less than that. Or the maximum number of students accepted into the college is 1,000. You have to have less than 1,000 or 1,000 or less. So that would be a less than or equal to. So when you're reading these word problems, take special care to note about what you're going to be using, greater than or less than, because they can be a little bit confusing if you don't take a moment to think about it. Least seems to be less than, and so we might accidentally put less than when we really should put greater than. So a couple of problem solving notes. Make sure you take note of those, and that will wrap this chapter up.